All right, so we will finish up, for the most part, probability today. We'll go over, we are planning a couple days of probability review the week we get back, a couple days of review before a quiz. The quiz is probably going to be the Wednesday you get back. So a couple days to kind of refresh, remind ourselves of the rules and so forth, and then a quiz. All right. So I did have to make a correction. That the answer key on number 16 was wrong in the book. So I fixed it. It did say set it aside. So it's out of 99 on that second draw. All right. So I'll take homework questions at the end. We're going to get right into the notes today. Is this the first thing at the top for you? All right. So we're going to remind ourselves of or probability. I'm going to try to do this visually and mathematically. So probability of a face card. Do you remember the or symbol?
It's a
Good. Yep, it's this one. Or a red, which is kind of confusing because that spells out fur. All right. All right. So face card or a red. Here we go. Let's count up the face cards. Because do you agree face card or a red, it means I'd be successful if I picked either one. Correct? Either pick a card out of a deck, it's a face card, or it's red. Correct? All the ones that have faces on them. All right. So the jacks, the queens, the kings. So, ready? Face cards. How many are there?
12.
Very good. 12. So, face cards. Remember our formula. It's P of F plus P of R minus P of F and R. Think of and as overlap. Remember the intersection of 619 and market? That overlap?
Is it then like the fraction of that it overlaps?
Let's just do it, and then I'll take your question. All right, what's the probability of drawing a face card? How many were there? 12 out of 52. Don't reduce yet. Reds. Here we go. Let's highlight the reds. Those are all the hearts and all the diamonds. Those are the red cards. How many red cards are there? 26 out of 52. Plus 26 out of 52. Minus. Now, the reason I like to do this example first is that it's very visual. I think it's like when you talk about picking cards out of the deck, if you don't see it, it's kind of like, I don't quite grasp it. But for you visual people, you can see the ones we counted twice, can't you? Or yesterday, you can see the part of the roads we paved twice or calculated twice. How much do we have to take away? How much did we over count? 6, right? Minus 6 out of 52. Think of the and as where it's both a red card and a face card. All right, so we got, remember, when we have fractions, we have common denominators. We add the numerators. We have 12 plus 26 minus 6. What is that?
14.
I just got 3 different answers. 32. Good. 32 out of 52. 32 out of 52. For the sake of time, I'll let you reduce that and find the percentages on your own. We're good at that now. Next one. Find the probability of drawing a 6 or a king. Probability of a 6 or king. Well, that's the probability of drawing a 6 plus the probability of drawing a king minus the probability that it's a 6 and a king. That would be the overlap. Here we go. What's P of 6? How many 6s are there? 4 out of 52. Plus, how many kings are there? 4 out of 52. How many cards are both a 6 and a king? None. 0. Minus 0. Right? Look up here. If you're not a good person at visualizing the cards, here's your 6s right here. Here's your kings. There's no overlap. No overlap there. No, nothing to take away. So we just add them together, and we get 8 out of 52.
If we have this on a quiz, will they put the cards up there for us?
Probably.
Okay.
Probably. Questions on OR. That's wrapping up OR probability. All right. You didn't have any questions on OR probability last night. All right. Next is called conditional probability. P of A given B. The probability of A given B. There's an extra and in your notes you can cross out after B. Now, the way I'm going to repeat this is it's the probability that A will happen given that B has already happened. Which seems confusing, okay? But give me a chance. Give me a couple opportunities to explain this to you. All right? If you're a formula person, there's the formula. P of A given B is P of A and B over P of B. We're also going to look at it from just a common sense approach. And it is important that you learn how to read it this way because it describes what you're going to do, okay? If you read it as P of A given B, we can add a couple words in there and say P of A given that B has already happened, okay? So let's do a couple quick marble, I don't know what these are, just pieces of paper in a hat, looks like, something like in a bag. How would we read this one? P of picking a green given we've already picked a red. Let's say it again. Probability of picking a green given that I've already picked a red.
So the line is given?
Given that, yeah.
Okay.
Given that. Okay? So what's the probability of picking a green given that I've already picked a red? Well, guess what? If I've already picked a red, one of those is gone. Do you agree? There's one less marble or piece of paper in the hat, and it's one of the red ones that's gone. So let's find the probability of picking a green given that one of the reds is taken out. How many greens are there? 4, and there's one less piece of paper. How many are there?
9.
I'm counting 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 ninths is the probability of green given that a red has already been picked. Okay? What about P of green given green? Well, what's the probability of picking a green given that a green has already been taken out? 3 ninths. I want to extend it one more way, all right? I'm going to roll this die and flip a coin. What's the probability? Listen very carefully. This is a great example to go back to if you forget conditional probability. All right, this is our go-to. These events are mutually exclusive, aren't they? They're independent events. Okay? If I roll the die first, is that going to affect whether I flip a head or a tail in any way? No. And vice versa, right? What's the probability that I roll a 3 given that I've already flipped a head?
1/6.
I hear 1/6. Now, for some people, this is like, I have no idea what you're asking me. So here we go. What's the probability that I roll a 3 given that I've already flipped a head? Do you agree when we did that red marble or the piece of paper, that green piece of paper, we assumed it was it was a successful event. We crossed it out. It was already taken out, right? We picked it out. We controlled it was green. It's out. Same kind of thing here. Ready? What's the probability that I roll a 3 given that I've already flipped a head? So here we go. What happens first, the rolling or the flipping? The flipping. Okay. So here we go. Ready? Tail. Do I roll the die? No, because it's given that I've already flipped the head. Let's keep going, okay? Do I roll the die? No. Head. Okay, so given that I've already flipped a head, what's the probability that I roll a 3? Well, isn't it just the probability of this second event happening?
Yeah.
It's 1 out of 6. What's the probability of rolling a 3 given I've already flipped a head? Well, if they're mutually exclusive, it's just the probability that the second event happens. Now let's go vice versa. Ready? What's the probability that I flip a head given that I've already rolled a 3? I could roll the die all day. I don't flip the coin until I've rolled a 3. So what's the probability of flipping a head given that I've already rolled a 3? 1/2, right? It's the probability of the second event happening. Does this make any sense to you? This is what I want you to go to, this example, when you think of conditional probability, okay? And we're also going to do these with what's called two-way tables. So in our blank here, we're going to put two-way probability tables are a way of organizing conditional probability. Is this your first example?
Mm-hmm. Yeah.
Excellent. So here's what we have. We have a classroom, and we have some grades. Must not be any Fs in this class. This is not your class, by the way. Luckily. It's a big classroom, by the way. So we have males in this column, females in this column. We have A's, B's, C's, and D's. And so we're going to be asked some information about this, all right? So the first thing I want you to do is find the totals of all columns and rows. So we'll need to know the totals because we're doing probability. We need to know how many it's out of. Simple probabilities to start, then we'll get into a little bit more complex. What's the probability of picking? Let me back up. I want to explain the scenario, okay? Pretend there are 91 slips of paper. 91 slips of paper in a hat or a bag or something. You with me? On the slip of paper, it has either male or female, and it has the letter grade they have in the class. It has those two pieces of information, okay? So if I draw a piece of paper out of the bag, what's the probability that I pick someone that has an A in the class? Well, how many A's are there?
27.
Out of?
91.
Nice. 27 out of 91. And I don't care about reducing right now. I just want to make sure you guys understand the probability here. What's P of C?
45.
Awesome. You'll see those on a quiz. Those are the ones we're hoping for, right? Next one. There's a typo. It shouldn't say W. That was, I guess, for women, but let's change it to an F for female. All right. So this next one, change that to an F, please. All right. And that's a and or an or symbol.
What's an
And. So where would I be looking for if it's, I pull out a piece of paper and it has an A and an F? How many are there?
15.
15. Do you agree? The A's and the F's are where it's both, right? Both have an A and a female. Yes? Okay. So what are the chances of picking a piece of paper that has an A and an F on it? 15 out of 91. Next, what's the probability of mud? Now, M or D? M or D? Well, what's our formula for or? Isn't it P of M plus P of D minus P of M and D? Right? What's P of M? 49 out of 91 plus, what's P of D? How many D's are there? 20 out of 91. And then is there any overlap? Is there any males that also have D's?
17.
Yeah, because here we go. Ready? We're in this column for males. We're in this row for D's. And do you agree these 17 were counted twice? Yes? Do you see the overlap? We need to take away the overlap. Minus 17 out of 91. 52 out of 91? 52 out of 91. So this is how we can do the same probabilities that we've been doing, only with what's called a two-way table. All right, two-way tables. Does that make sense? You need to use the formula and then take away that, using that formula to take away the overlap. All right, next. Now we're on to some conditional probabilities. All right, I think you guys are doing really well. I do want you to pause for a second. I see some of you guys really working ahead. Okay, and I get it. Some of this stuff's really easy. But for this next one, pause what you're doing. I want you to look up here. I want to explain the way you should be looking at this. Okay. How do we read this again? P of M given B, right? This is the point in this problem where the denominator changes. Okay? We're not out of 91 anymore. Because we're trying to find out the probability of picking an M given that it's a B. So guess what our new, it's called a population. Guess what our new number of pieces of paper is now? P of picking an M, given that it's a B. Okay, so here's what happens. Ready? That hat or bag, whatever, that has all these slips of paper in it, it gets changed. What's only in the bag now? The B's. P of M, given that it's a B. Okay, so everything else other than B's have been taken out. Only the B's are left. So how many slips of paper are we picking out of now?
17.
How many B's are there?
19.
19.
What? Oh, the other one.
Okay, that's my new total. Yes? What's the probability of picking an M given that it already has a B on it, on that slip of paper? Isn't it 6 out of 19? It's 6 out of the total of 19. Do you need me to explain that again? Tell.
I'm kind of confused with it.
So do you remember the die roll and the coin flip? What's the probability that I rolled a 3 given that I've already flipped a head? Okay. Well, what had to happen first in this? I had to only be looking at the slips of paper that had B's on them.
So you read the second one and that's what's already done?
Yeah, so it's given that it's a B, okay? So I'm only looking at the B's right now. And what's the probability that I pick a male out of the 19 B's? Well, it's 6 out of the 19, okay? Let's do the next one, and then if you still have questions, we'll keep asking. Do you see how the letters have switched places, correct? Let's read it again. P of B given M. So now what are the only things on our hat? M's, right? M's. How many M's are there? Here are the M's. There's 49. Right now I know my denominator is 49. And what's the probability of picking a B out of that? Well, how many B's are there? 6 out of 49. Tally, does that make any more sense? Everybody else? Feel okay about that? That's called conditional probability. Conditional because something had to happen first. A condition had to be met first before you even do the second item. All right. I'm going to put the assignment up right now. If some of you are comfortable with all that, the two-way tables and all that, you're welcome to start this assignment. Okay? If you want me to go through another one of those two-way tables, I will. So go ahead and write this down, please. All right, just another couple seconds.
Very conservative.
Yep. How many F's are there?
Mr. Westphal, you keep making me think I'm doing it. I just finished my whole thing and I did it. 27. 26. Gosh. See, you're doing it to me too. Right. Mr. Westphal, is that a new jacket?
Nah, I'm just cold. All right, so or and? Or. So we want to do P of C plus P of D minus P of C and D. So P of C, 18 out of 97 plus 13 out of 97 minus, how many are there that have a C and a D on them?
7.
A C and a D.
Oh, C. None.
None, right? There's no overlap between the C column and the D column. So did you get, what's that, 31 out of 97?
Yeah.
All right. F and D. So when you think and, you should be thinking overlap. So F and D. How many F and Ds are on it?
0.
0 out of 97.
Wait, why? It's a chance to hurricane. Give it.
All right. Now I'm going to have to scroll up a bit.
All
All right. A and, let's do the A and F one next. A and F. 12. Good. A column, F row, 12 out of 97. All right, let's do A or F. P of A plus P of F minus P of A and F. All right, P of A, we already had these figured out, right? 28 out of 97. And the P of F already was 26 out of 97. And we're subtracting off where it was both, which we've already done, which was 12 out of 97. So what's that, like 42 out of 97?
Yeah.
Thank you. All right, let's do P of A given F. So given that it's in the F row, find the probability that it's A. Well, there's 12 A's out of the 26 in the F row. 12 out of 26. Make sense?
Okay, on the worksheet for this, would you add them to me? Okay, they're right.
Yeah, hold on a second. P of F given A. So now we're looking. P of F given A. 12 out of 28. Page. Yeah. Pages on one watching.
I'm watching. I just have questions once you're done.
All right. P of F given C. All right. P of F given C. 1 out of 18. And P of D given G.
but also 4, so that's 4. Yeah, 4.
We have D. Given G, 6 out of 45.
There's no 3.
Alright, P of not C.
Let me.
4 over 12 plus 1, 3, 5, 6, which makes sense. Oh, I had to do that. Wait. Is it 3? Oh, wait, never mind. I thought 2 was on. I thought
Any questions on the extra problem?
Ted says 8 12, right? Wait, is that?